Tonight, you will lose consciousness for roughly 8 hours. Your body will go limp, your eyes will roll back, and a part of your brain will start generating hallucinations so vivid you will believe they are real. You call this sleep. But what is actually happening inside you is far stranger than you think. Most people assume sleep is just rest, a long pause, the brain powering down so the body can recover. That is the common sense version. That is also almost completely wrong. Sleep is not passive. It is one of the most violently active states your brain ever enters. And the reason your body forces you into it every single night, whether you want to go or not, reveals something surprising about what you actually are. Start with the basics. You cannot stay awake forever. Nobody can. In 1964, a 17-year-old named Randy Gardner decided to find out exactly how long a human could go without sleep. He lasted 11 days and 25 minutes. By the end, he was hallucinating. He could not complete simple sentences. He forgot who he was mid-conversation. His brain had started to dissolve its own sense of reality just to get him to stop. That is not a malfunction. That is your brain doing exactly what it was designed to do. It was forcing a shutdown. But why? Why does a brain that runs on electrical signals and chemistry need to go offline at all? For most of the 20th century, scientists assumed sleep was about physical recovery. Muscles rebuilding, cells repairing. The boring maintenance work the body saves for quiet hours. That was the accepted answer for decades. Then a neuroscientist named Maiken Nedergaard discovered something in 2013 that rewrote the entire conversation. Your brain is surrounded by a system of tiny channels, a kind of plumbing network that scientists now call the glymphatic system. During the day, this system runs quietly in the background. But when you fall asleep, specifically when you reach deep sleep, something extraordinary happens. The cells in your brain physically shrink. They contract by up to 60%. And the space that opens up between them floods with cerebrospinal fluid, which rushes through those glymphatic channels like a pressure wash. What is it washing out? Waste. Toxic waste. Metabolic byproducts that your brain produces simply by thinking, including a protein called amyloid beta, which, when it accumulates, is one of the primary markers found in the brains of people with Alzheimer's disease. Your brain spends every night pressure washing itself clean of the very debris that, if left behind, begins to destroy it. You are not resting when you sleep. You are running a full biological detox every single night. And that is only one layer of what sleep is doing. Go deeper. When you close your eyes and drift off, your brain does not simply go quiet. It cycles. The first thing that happens is your body temperature drops, your heart rate slows, and your muscles begin to relax. A stage called non-REM sleep, which itself moves through 3 distinct phases. The deepest phase is where Nedergaard's glymphatic cleaning happens. It is also where your body releases the highest concentrations of growth hormone, where cell repair accelerates, where your immune system ramps up production. Your body treats deep sleep like an emergency maintenance window that cannot be skipped. Then something shifts. Around 90 minutes after you first fell asleep, your brain does something bizarre. Your eyes start moving rapidly beneath your closed eyelids. Your heart rate becomes irregular. Your breathing changes. Your body becomes temporarily paralyzed from the neck down, and your brain lights up on a brain scan in a pattern almost identical to being fully awake. This is REM sleep, rapid eye movement sleep. And what happens here is stranger still. Your prefrontal cortex, on the part of your brain responsible for logic, planning, and reality checking, goes nearly dark. But your emotional centers, your memory centers, and your visual processing regions flood with activity. This is the state in which you dream. And for a long time, dreams were considered noise, random firing, the brain processing junk signals while it idled, a kind of neurological screensaver. Matthew Walker, a sleep scientist at the University of California, Berkeley, and author of one of the most widely cited works on sleep research, describes REM sleep as something closer to overnight therapy. During REM, your brain replays emotional memories, but it does so without the chemical that makes fear stick. A molecule called norepinephrine, which is associated with stress and anxiety, is completely absent during REM sleep. So your brain revisits difficult experiences in a low-threat chemical environment. It can process them without the emotional charge that made them painful in the first place. You have had the experience of waking up after a hard conversation or a humiliating moment and feeling like it does not hurt quite as much as it did the night before. That is not time healing the wound. That is REM sleep doing surgery on it while you were unconscious. And Walker's research goes further. People who are deprived of REM sleep show measurably increased amygdala reactivity, meaning their emotional brains become hypersensitive, firing 60% more intensely at neutral stimuli than well-rested people. A bad night's sleep does not just make you tired, it makes the entire world look more threatening than it actually is. Now, here is where it gets counterintuitive. For thousands of years, for almost all of human history, people did not sleep the way you sleep. The idea of a solid 8-hour block of uninterrupted nighttime sleep is not the human default. It is a modern invention. And the evidence for this comes from a surprising direction. A historian named Roger E. Kirch spent 16 years combing through pre-industrial diaries, court records, medical texts, and literature from across Europe. What he found was that before the widespread use of artificial lighting, most people slept in two distinct phases separated by an hour or two of wakefulness. They called it first sleep and second sleep. People would fall asleep at dark, wake naturally around midnight, spend time talking, reading, praying, or having sex, and then fall back into second sleep until morning. This pattern appears in documents from ancient Rome, in medieval France, in references by Chaucer, in the medical literature of the 1500s. It was not insomnia. It was simply how humans slept. The invention of the gas lamp in the early 19th century, followed by the electric light bulb, pushed social activity later into the evening, which compressed the natural window of sleep and eliminated the middle waking period entirely. Most of the anxiety that modern people feel about waking up at 2 a.m. and not being able to fall back asleep is, in historical terms, completely normal. Your body is doing exactly what it evolved to do. What changed is not your biology. What changed is the light, which brings you to the question you probably did not know you had. If your sleep is shaped this deeply by light, by the presence or absence of it, what does that say about screens? About the blue-lit rectangle you stare at for hours before bed? Your brain tracks light through specialized cells in the eye called intrinsically photosensitive retinal ganglion cells. These cells feed directly into a tiny cluster of neurons in your hypothalamus called the suprachiasmatic nucleus. Your master internal clock. This clock is exquisitely sensitive to the wavelength of light. Blue light, in particular, is the signal it reads as daylight, as morning, as the time to suppress melatonin and prepare the body for wakefulness. When you look at your phone or your laptop at 10 o'clock at night, your suprachiasmatic nucleus receives a message that is almost identical to looking at the morning sky. It tells your brain it is not time to sleep. It delays melatonin release by anywhere from 90 minutes to 3 hours, depending on how long you were exposed and how bright the screen was. You are not just delaying sleep. You are confusing the ancient machinery that governs when you are alive and when you are not. You are sending your biology into a time zone it was not designed to occupy. Charles Czeisler, a circadian neuroscientist at Harvard Medical School and one of the foremost researchers on sleep and light, has spent decades documenting what happens to human performance when sleep is disrupted. His research found that after 17 hours of wakefulness, cognitive performance degrades to a level equivalent to a blood alcohol concentration of 0.05%. After 24 hours without sleep, that figure reaches 0.10%, legally drunk in most countries. And unlike alcohol, which you can feel, sleep deprivation numbs your ability to perceive how impaired you actually are. You feel fine. You are not fine. There is one more thing nobody tells you about sleep, and it might be the most important. Sleep is not just restorative, it is generative. During deep sleep, your hippocampus, the brain's short-term memory hub, plays back the experiences of the day and transfers them into the cortex for long-term storage. This process is called memory consolidation. And without it, learning does not stick. The information you studied the night before an exam, the skill you practiced, the face you tried to memorize. Without sleep, these things do not become permanent. Walker's research showed that students who pulled all-nighters before exams performed measurably worse than students who studied less but slept fully. The sleep, not the studying, is what turns short-term experience into permanent knowledge. Sleep is not the reward at the end of a productive day. Sleep is the mechanism by which the day becomes part of you. So tonight, when you turn off the light and close your eyes, something remarkable is about to happen. Your brain will begin its cleaning cycle. Your emotional memories will be quietly diffused. Your immune system will surge. The experiences of your day will be written into long-term storage. And your ancient biological clock, calibrated over millions of years to the rhythm of the sun, will do what it was built to do. Tonight, you will lose consciousness for roughly 8 hours, and every second of it will be the most productive time you spend all day.